Hey guys, this is lesson 4.9 for pre-algebra. It's called scientific notation. So it really is just that. It is something you're going to use in science. So scientific notation is written as the product of two factors. One that's greater than or equal to 1 and less than 10. So it's a number between 1 and 10. Has to be greater than 1 and less than 10. And it's a power of 10. So if I had this huge number, if I had this big, huge number, maybe that's the distance from the moon to Jupiter, they, in science, write it like this: 7.5 times 10 to the 12th power. So it's just a lot easier to write than to write it all out. So, writing in scientific notation. Whenever you have a huge decimal, like 450 million, you can write it easier by writing 4.5 times 10 to the 8th. So here's how you do it. You take your number, make it a little bit bigger here, take the number, and you start here at the end, the decimal point. Now, I'm going to frog jump however many spaces it takes me to get to a number. I want a number between 1 and 10. So I'm going to jump 1, 2, 3, 4, 5, 6, 7, 8. I jumped 8 times and I got to 4.5. That is a number between 1 and 10. That's what you want to do. You want to get between these first two numbers. So what you write is 4.5 times 10 to the 8th power. However many little frog jumps you made, that is your exponent. Because every time I frog jump, I go from the ones place to the tens place to the hundreds place to the thousands place to the 10,000s place to the 100,000s place to the millions. Every time you're frog jumping, you're going up by a power of 10. So that's why it's times 10 and then to however many times you jumped. It's like you're multiplying it by 10 every single time. So, try these two problems. Write in scientific notation. So, this first one, I'm going to start here, and I'm going to frog jump. 1, 2, 3, 4, 5, 6, 7 times. Now, I didn't stop right when I hit my first number. I always stop between the first and the second number. You're always stopping there. So this is 5.45. I can write all the numbers after the decimal times 10 to the 7th. Remember, this is however many frog jumps you did is your exponent. So this one, I'm going to start here. I'm going to jump 1, 2, 3, 4, 5 times. And I get 7.23. That is a number between 1 and 10 times 10 to the 5th power. So you're always trying to get a number between 1 and 10 as you're beginning. If they want it to make it sound a little bit smaller, 7.23. When you hear the word 7, it's a lot smaller than 723,000. So, writing in standard notation, now this one, if I gave you 2.5 times 10 to the 9th and said that's the approximate population, could you figure that out? How many people is that? So now what you do is you take this number, 2.5, which is a number between 1 and 10, and I'm going to move my decimal point 9 hops. And I move 9 hops because that's my exponent. So I'm going to move 9 times. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved 9 spots, and now they're all empty. So what you fill them in with is zeros, because every time you're multiplying by 10, you're adding a 0. So then I look back and I can write this out as 2,500,000,000. And this is my normal, regular, standard form of a number. All right, so write each number in standard notation. So this first one you can do. So try that, and then I'll show you what to do for B. All right, so this one is 3.21 times 10 to the 7th. So I'm going to move 7 times. 1, 2, 3, 4, 5, 6, 7. So that equals 32,100,000. So there is standard notation. This next one now, notice the difference. Here's the difference. This was a positive 7 and this is a negative 8. Now if you remember from the previous lesson, the negative sign does not make it negative. It makes the number smaller. So instead of, I take my number 5.9 and instead of making it bigger by going to the right, they want me to make it smaller because it's a negative 8. So this time I'm going to go to the left. 1, 2, 3, 4, 5, 6, 7, 8 times. And then I fill these in with zeros. Now this is like the size of a water molecule. It's something that's super, super tiny that you really can't measure without a microscope. So then there's your answer. And then the last one is 1.006 times 10 to the 10th. So you have 1.006, and I'm going to move it 10 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my answer then in standard form is 10,060,000,000. Okay. Lastly, they're going to ask you to compare and order numbers. So, here it says, order these numbers from least to greatest. There's the key point, least to greatest. So in your notes, I want you to write this. You don't have to write all of this down. I want you to write this. If my number goes up, so from 0.064 to 6.4, my exponent goes down. So if the number goes up, the exponent goes down. If the number goes, let's see what one goes down. So 3.12 went down to 312 went down to 3.12, then my exponent goes up. So it's a little bit tricky. So what you want to do whenever you're given 3 different scientific notation numbers, you want to make sure they're all written in scientific notation. So if I look at these numbers, just step back and look at these that they first gave you. It looks like they're all in scientific notation. But then, look. Okay, here's my numbers. Then look, is this a number between 1 and 10? No. Is this a number between 1 and 10? No. Is this a number between 1 and 10? No. So none of them are written in scientific notation. They're not properly written. They're trying to fool you. So what you have to do is change them. So then here they changed it to 6.4 times 10 to the 6th. So my number was a tiny decimal and it went up to 6.4. So my power goes down. This 312 went down to 3.12 and my exponent goes up. And then this number goes up and my exponent goes down. Now I can order them. So now you'll be able to order them. You just look at the decimal points and you can see which one's the smallest first by the exponent, 10 to the 4th. So that one is the smallest, and they wrote it as this normal regular one. And then you look at the next one, okay, so 5.8 is smaller than 6.4, so that goes next, and then 6.4 goes last. So try this problem in your notebook, and then we'll see how we do. So our first step is to change each of them into scientific notation. So 526, I'm going to change to 5.26. My number was big, and it went down, went from 500 to 5, so that means my exponent goes up. So this is 526, I moved 2 times, so I add 2 exponents. I moved my decimal point 2 times, so I add 2 tens. This one, I'm going from 18.3 and I'm going to move my decimal point 1 time to 1.83. My number's going down, so my exponent goes up 1 time, however many frog jumps you have. And then lastly, I move this 2 times, and my number's from 0.098, it goes up to 9.8. My decimal's going up, so my exponent goes down to 7. So that completely changed all the exponents. So now I can see which one is the smallest, okay? And it has to be between one of these because they're both 10 to the 7th power. And then I look and I see, okay, 1.83 is the smallest, so 18.3 times 10 to the 6 is the smallest, and then 0.098 times 10 to the 9th is the second, and then lastly it's 526 times 10 to the 7th. So that is it for your notes on scientific notation.